The Stable Diffusion XL 1.0 model is out and it's a revolution for image generation. But how exactly can you train it with your own images? Well, you can do that very easily with the help we're gonna use to make our LORAs. And to install it, you have two options. The first and easiest way is the automatic one-click installer that I created, and that is available for my Patreon supporters. And then once you've downloaded the file, just double-click on the Koya SS Auto Installer, and then it will automatically install everything that you need. And speaking of Patreon, if you're not a Patreon supporter right now, I highly recommend that you do if you can. Because in this video, you'll be very happy that you are one, believe me. Because you're gonna receive a lot of cool stuff. And the other way to install the Koya SS GUI is of course the manual installation. And I'm gonna show you how. Now the first thing that you need to install is the Visual Studio distributable packages, that are basically some Microsoft libraries that will allow Koya SS to run. So just click the link in the description down below, you're gonna arrive on this page, and then you're gonna click on this link right here, which will download an exe file onto your computer, which you can then run and install. And the next two things that you need is Python and Git for Windows. And if you already watched and followed my previous Stable Diffusion installation video, these should already be installed for you, which would make sense if you're watching this video right now. But if for some reason you haven't done that, go watch my previous video to download and install Stable Diffusion. I really explain everything there. So once you install everything, you're gonna create a new folder on your computer. I called mine Koya, and then you're gonna click on the folder path, type cmd, press enter, and here you're gonna copy and paste this command line that you will find in the description down below, and then press enter. And this will create a brand new folder called Koya SS. And if you go inside that folder and you scroll down, you will see a bunch of files. But the one you need to click right now to install the software is setup.bat. So you're gonna double click on this file, which will then start the installation process. And after a while, you will see these options. And here what you need to do is just press 1, which basically corresponds to install Koya SS GUI, and then press enter. Here it's going to ask you to choose between torch 1 and torch 2. So here you're going to choose torch 2. So press 2 and then press enter. And then it's going to start installing a bunch of requirements that it needs to run. Now this might take some time for some people, so definitely be patient and wait until everything is done. And there you go, after around 5 minutes, it has finished downloading and installing all the packages. And then it's going to ask you which compute environment are you running. So of course in my case it will be this machine. So I simply press enter. Then it's going to ask you what type of machine are you using. So here in my case, I will be using no distributed training, so I'm just gonna press enter. And then it's gonna ask you if you want to run your training with CPU only, which in my case is definitely gonna be a no. I definitely want to use my GPU for that, so I'm gonna type no, then press enter. Do you wish to optimize your script with Torch Dynamo? You're gonna say no again. Do you want to use deep speed? Again, you're gonna press no. Then what GPU should be used for training? Here you're gonna type all, then press enter. And then it's gonna ask you to choose between FP16 or BF16, which is basically half precision training. And here, depending on your GPU, you should either use FP16 or BF16. So if you have an NVIDIA GPU 3000 series or more, you should use BF16. And if not, you should use FP16. Now in my case, since I have a 3090, I'm gonna have to choose BF16 and then press enter. And there you go, now the entire installation is complete. Now the only thing that we need is to close this window, and to launch Koya SS GUI, all we need to do is just double click on the GUI.bat file, which will then give you a local URL. Now if you're like me and you're a little lazy, and you don't want to click on this URL each time that it launches, and you want to do it automatically, what you can do instead is right click on the GUI.bat file, edit with Notepad, and then here on line 21, after Koya_GUI.py, you're gonna type -- in browser, and then you're gonna save the file. And now if you double click the GUI.bat file again, it will automatically launch a brand new window. And this is the Koya SS GUI. This is where we're going to be spending a lot of time. And it is an amazing piece of software, where you can train the Dream Booth, LORA, text to inversion, fine tuning, etc, etc. It is really an amazing software. But before we start the LORA training, we actually need to do the most crucial part of this entire operation, which is dataset preparation. Or more simply, just here you're going to input the directory for the training images. For this, I'm going to click on this little icon, then select my image folder, and here it's going to ask you to select the folder for your regularization images. Now, regularization images are basically a bunch of images that correspond to your class prompt, that are basically used to avoid overfitting and class preservation. Now it's a little complicated to explain, but basically it will make the model more flexible and more precise. And they're always linked to the class prompt that you're trying to train. And for the regularization images, you not only need to have a bunch of them, but they also need to be of very high quality. So for this, you can either find them yourself online, or again come on my Patreon page, where I basically prepare for you a bunch of regularization images. And I gotta tell you, this took me several hours to make, because for each class prompt, you will find 1000 ultra high quality images of 1024 by 1024 resolution. There is 1000 images of men, 1000 images of women, 2000 images of person, and 1000 images of art style. And they're both available in 1024 by 1024 resolution or 768 by 768 resolution. So if you want to train Stable Diffusion XL models, these regularization images are absolutely essential. They took me a really long time to make, but they are definitely worth it. And if you are one of my Patreon supporters, you will have access to all of those images on my Patreon page. Oh, and speaking of Patreon, today not only you will receive the Koya SS Auto Installer, the Stable Diffusion XL preset files, the thousands of regularization images, but you will also receive 4 LORA models that I created. Billie Eilish, Cillian Murphy, Margot Robbie, and Millie Alcock, where they all not only have the model inside, but also the dataset used with the image captioning, so that you can easily better understand how the training was done. And not only that, if you're one of my Patreon supporters, you might also request a LORA that is not available online. And every week I might do a poll on my Patreon page so that my Patreon supporters can vote on what model they want me to create. And all of those private models will only be available on my Patreon page. So if you're interested in having a LORA that is not available anywhere, well, you'll maybe be able to find it on my Patreon page. So definitely vote on the poll and tell me what LORA you want to see. But here, for example, in our case, since we are training a woman with the class prompt woman, we're gonna choose the 1024 by 1024 resolution of the 1000 woman images that for me are located right here. So then here you will see the repeats option. This is basically how many passes each training images will receive. But this is very easy, to not be afraid. For the repeats, the number that I always use is 20. This is really not the most important part, because the most important training parameters will come later. And then here, for the destination training directory, you will choose where the new folder structure will be created. So in my case, I think I'm gonna create it right here. And then you're gonna click on prepare training data. And now if you go to this folder location, you will see that we have now 4 brand new folders: image, log, model, and reg. If you go to inside the image folder, you will see another folder inside called 20_ Sasha Loss Woman. And what this basically means is that this 20 is the amount of repeats each image will receive with our instance prompt, Sasha Lush, and the woman as our class prompt. And these parameters will basically be read inside the training in the Koya SS GUI. And now what you need to do is just click on copy info to folders tab. And now that this is done, if you go back to training and then click on folders, you will see that before we had nothing, but now each section is populated with the location of our training folder. And the only thing that you really need to change is the name of our model output. So what I recommend you to do is first to input the name of the character that you're trying to train. So in my case it will be Millie_Alcock, and then create a dash with the name of our instance prompt, so that we never forget what name that we need to use. So in our case it was Sasha Loss. So then this way, when this will be in our database, in our collection of LORA, we know what character we're looking for, and then we know what name we need to use inside our prompt, so that there's basically no way to forget. And then when this is done, you're gonna click on parameters. And here you will see a bunch of options. But don't worry, because as I said previously, because we input here our configuration file that you will find on my Patreon, everything is already done for you. You literally don't have to do anything. But before I go and explain all the important parameters, there is something that we need to do first, and that is image captioning. Now, image captioning is basically creating a new text document for each image where you're gonna describe the image. And the reason we do that is that caption helps the model understand what you're trying to train, which in the end makes the model way more flexible. Now, technically, if you're training a simple character, you don't necessarily need to do the captioning, because the AI model is smart enough to understand that you're trying to train a new person person. However, if you're training a style or a concept or an object, this step is crucial, because otherwise the model will have a hard time understanding what you're trying to train. And even if you don't have to do it on a person, I still highly recommend to do it, because it will make the model more flexible and just better, especially because it doesn't really take a lot of time. And that is because we're going to be automating half of it thanks to a Koya SS tool, because if you go to utilities and then under captioning you click on blip captioning, it will actually do half of the work for you. By using an AI model called blip, it's going to analyze every single image in your folder and then automatically describe what's inside. And to use this is very simple. You're just going to click on this little icon to find your folder images. So here you're going to leave the caption file extension at .txt. You're just going to leave it by default. But there is one thing that we need to add, and that is a prefix for the blip caption. And basically what we want to put here is the name of our character that we're trying to train. But remember, we're not trying to train Millie Alcock, we're trying to train Sasha Loss. So basically here for the prefix, I'm simply gonna write the name of the character that we're trying to train. And in our case, it's Sasha Loss. And then for the other parameters, you can just leave them by default. And then click on caption image. So then it's gonna load the blip model and then caption our image. And now if we take a look at our folder, you will see that each one of our image has now a corresponding text file. And now if we open it, you see that inside we have a description of our image. So if we take a look at our first image, you basically see Millie Alcock in her Rhaenyra outfit in the House of Dragon series. And for the caption, we got Sasha Loss, a woman in a red dress with a necklace and earrings, which is already a pretty good base. However, we could probably make it better and put something like for example, Sasha Loss, a woman in a medieval red dress with white hair and necklace and earrings. As you can see, all we have to do is just describe the image in the most precise way possible. And basically, you're gonna do that for each and every caption. Basically, you're gonna describe the character, what she's wearing, what accessories she has, maybe even the background if needed, and your goal is just to make the caption more accurate so that the AI model understands perfectly what the image is all about. Simple as that. And so when you're done, when you finish captioning every image, you're gonna select all of your captions, copy them, and then you're gonna go inside the folder that we created previously with all of our new folder structure. You're gonna go inside the image folder, D20 Sasha Loss Woman, and then you're gonna paste those captions right here. This way, with the Koya SS, we'll have access to this folder. It will not only see the images of the character that you're trying to train, but also the caption for each image. Okay, so now that we prepared our dataset, it is time to look at the training parameters. Now again, hopefully, if you are a Patreon supporters and you have access to the configuration files, you are basically done. Everything is already done for you. All you need to do is just scroll down and click on Start Training. However, I will still explain a few parameters so that you know what you need to change depending on what you want to train. And here we're gonna start with train batch size, epoch, and save every n epochs. Now basically, batch size is the amount of images that are processed all at once. And the bigger the number, the more VRAM it's gonna use, but the faster the training will be done. Now when it comes to epoch and save every n epochs, epoch basically means a cycle of training. Remember when here we inputted 20 for the repeats? This is basically the amount of steps per image. So if you have 10 images, it will basically be equal to 200 steps. So if for epoch you put 1 here, this will basically be equal to 1 cycle of training. If for epoch you put something like 5, it will be equal to 1000 steps, or 5 cycles of training. Now technically you don't even need to use epoch, because this is basically just multiplying this number. So if you want I don't know, 2000 steps of training, you could just input 2000 here, and then input 1 here, and that's it. However, if you do that, you will not be able to understand when your model is undertrained or overtrained, which is why we divide the entire training into several cycles, or what we call epochs. And that is thanks to this little option right here that allows us to save every n epochs. Because here, let's say that we have 20 repeats and then 10 epochs, and that we save every epoch. If we have 10 images and then multiply them by 20 steps each, then we'll multiply that by 10 cycles of training. We then get 2000 steps of training, which is the equivalent of 10 cycles, where in the end, we should have 10 saved models, which will make determining which model is the best Very easy. Now the reason why batch size and epoch are all connected is because again the higher the batch size, the more the total steps are gonna be divided. So if you input 9 for the batch size, you're gonna have 2000 steps divided by 9, which will be equal to 222 steps, which will make the training much faster, but again use way more VRAM. Now a lot of people online will tell you to not use a higher batch size when you're trying to train a character, because for some reason it will make the image look blurry, but in reality is not exactly true. What a higher batch size will basically do is create a smoother transition between models. Like for example, you see here that this is a model trained on Billie Eilish, trained with batch size of 1, and you can see that there is a stark difference between every model. Like every model looks very different compared to one another. However, here you have a model of Billie Eilish trained with a batch size of 5. And you can see that the transition between all the models are way smoother, which creates a model that is more flexible, meaning that you can easily add a style to the model compared to a model that is trained on a batch size of 1. Which is why when you're trying to train a style, for example, it is better to have the batch size as high as possible to have a very flexible model. And it's also very useful if you're training with a very large dataset, because if you put the batch size at 1, the training will last forever. However, no worries, even if you use batch size of 1, the only difference is that you will just choose another model in the epoch training, compared to a model trained with a batch size of 5. Now don't worry if you don't understand everything, I will show you later in the video how to choose the best model, so that it's not undertrained or overtrained. But basically here my advice, if you're trying to train a character like a real person, I recommend keeping the batch size at 1, which will make the training a little bit slower, but for most people who have a low GPU with a low VRAM, this is probably the best choice. And if you're trying to train a style, for example, you may want to increase that batch size to something like 5. But again, no worries because I prepared the style preset for you to use. So again, you don't need to do anything. But yes, in our case, since we're training a character like a real person, we're gonna input a batch size of 1. So then here for the mixed precision and safe precision, in my case I input BF16 for both because I have a 3090, but remember, if you don't have a 30,000 series graphics card or newer, you need to use FP16 instead. So then here the number of CPU threads per core and seed, you're not gonna touch anything, just leave them by default. Make sure that cache latents and cache latents to disk are checked and that the caption extension is .txt, because this is the extension of our caption that we inputted previously, as you can see right here. So then we go to the learning rate. The learning rate. I spent a lot of time trying to understand what is the best learning rate for training. I trained over 30 models to see which one is the best. And my advice to you for the learning rate is to input a value between 0.0001 or 0.0003. Now the reason why I gave such a wide range is that in the end it really doesn't matter. Yeah, that's right. Because with those learning rate and the amount of epoch that we input right here, after a while you will find the right model for you. Like for example, this model was trained with a learning rate of 0.0001, while this one was trained with a learning rate of 0.0003. And the only difference is that basically the higher the learning rate, the sooner you'll be finished with the model. So like for example, if I were to choose a model trained with a low learning rate, I would probably choose a model between 4 and 6 epoch, whereas if I was using a higher learning rate, I would probably choose a model created on the epoch 3 or 4. But the thing is that it really depends on each model. Some model you'll be finished earlier, and some model you'll be finished later. It really depends on the character that you're trying to train, the amount of images, and just the fact that every person is different. But don't worry, again, no matter what you do, no matter what learning rate you input here, as long as it is between 0.001 and 0.0003 and with 10 epochs, your model will always succeed. Because training a LORA on SDXL is really easy once you have the right parameters. They are very easy to train, they're very flexible, and as long as you have good images, it is very hard to fail. And that is definitely good news. So here for the learning rate scheduler, you're gonna input constant with a warm-up of 0 and use the optimizer at a factor, which is the optimizer that uses the less VRAM. But also do not forget that if you use this optimizer, you need to input these extra arguments. Scale underscore parameters equals false, relative underscore step equals false, and warmup underscore init equals false. I will put these arguments in the description down below, so you can just copy and paste them right here. Okay, so max resolution. This is the resolution at which the images will be trained, and the default value for SDXL is 1024 by 1024. However, do not forget forget that the higher the resolution here, the more VRAM it's gonna use. So if you want to save on VRAM, instead of inputting the full resolution of 1024 by 1024, you can input a resolution of 768 by 768, which of course will not make as good model that if we were using the full resolution, but again it will definitely save on the amount of VRAM that your GPU uses. But obviously, if you can, definitely put this at a max resolution of 1024 by 1024. Oh, and by the way, if you also want to train the style, a max resolution of 768 by 768 is also good. But again, obviously a high resolution is always better. So then here you have an amazing option called Enable Buckets. Now this option is the reason why we don't need to crop our images, because it will basically take our images at face value the way they are and train them at high resolution instead. So definitely leave this option checked. So then here for the text encoder learning rate and the unit learning rate, you're gonna input the same as our learning rate right here. So if you have 0.003, you're gonna input the same here and here. And if you have 0001, you're gonna input again the same here and here. But obviously in our example, we use the learning rate of 0.003. So then here for the SDXL specific parameters, you're gonna check no alpha VAE, and if you can check cache text encoder outputs, which will basically reduce the amount of GPU VRAM usage. But unfortunately as of right now, this option is a little broken. So until they fix it, do not use this parameter. So then you have the network rank and network alpha. Now basically the network rank is how much detail the model is gonna retain. But at the same time, the higher the number, the bigger the LoRa file is gonna be. Now a lot of people actually privilege having a very high network rank because they want to retain as much detail as possible, which is of course understandable. However, the difference between them is not that big. Like for example, this is an image of a Cillian Murphy model that weighs 160 megabytes, and the one on the right is the same model but made with a higher network rank and that weighs 1.7 gigabytes. And indeed you can see that there is a few differences between the images. The image created with the bigger model is definitely way more precise, and the Koya SS will start the training of our model. And as you can see, in our case, we have 4,800 steps of training with only 12 images. And in my case, 4,800 steps of training will take around 2 hours. Yes, I know, it's quite a lot, but in reality you don't really need to wait that much, because the model that we're gonna be using is not the one at 10 epochs. The reason why we put 10 epochs right here is that we want to choose the best model possible, and I'm gonna show you later in the video. And as of right now, this entire training is taking around 20 gigabytes of VRAM. But do not forget that I am recording a video and I have also a bunch of applications running in the background. So for you, it will be probably around 19 gigabytes instead. But don't worry, even if you don't have a powerful GPU like a 3090, I have here a low VRAM preset that you can use that will basically knock down that VRAM requirement to around 12 gigabytes of VRAM. So in theory, you should be able to train a LoRa SDXL on around 12 gigabytes of VRAM. However, I hear you say, what would happen if I don't have a GPU? What if I don't even have 12 gigabytes of VRAM to begin with? Well, I'm gonna show you what I actually used these last few days. Because that's right, these last few days, I did not even use my computer to train LoRa models. What I used instead is a GPU renting site called RunPod, where you can basically rent a GPU for a few cents an hour. And this is what I've been doing all along, renting several pods all at once so that I could compare the results. Otherwise, this entire thing would probably have taken me an entire month. And again, I'm not sponsored by RunPod, I really just like their services, and I've been using their website for over a year now. But the reason why it is so good on RunPod is because there is a specific template. Because if you click the link in the description down below, you will see that it will have selected a very specific template, and that is the Stable Diffusion Dreambooth ControlNet Deforum Root Koya. Yeah, that's right, that's a mouthful. But basically this amazing template will install Stable Diffusion, Dreambooth, ControlNet, and Roop on a powerful GPU. And you can use that to train a model from scratch and then try that model without leaving the website. And all of that for only a few cents an hour. This is definitely cheaper than buying a real GPU. And to use this is very simple. Again, you can click the link in the description down below, create an account if you haven't already, and then it's going to select this very specific template, which will then ask you to pick a GPU to deploy. And the GPU that I definitely recommend is either a 3090 or a A5000. You basically need a GPU with 24 gigabytes of VRAM minimum. So then you're gonna click on deploy, click on customize deployment, change the container disk to something like 50 gigabytes, click on set overrides, click continue, and then click deploy. And then you will see that your pod is being built. And then if you go to my pods, you will see that your pod is now ready to be used. And then if you click on connect, you will see 4 different options. And again, I gotta tell you, this template is amazing, because if you click on the first link, it will open the automatic 1111 Stable Diffusion Web UI that you can just use and generate images. If you click on the second link, it will open the Koya SS GUI, where you can train your LoRa model exactly the way we did on our local computer. And if you click on the fourth link, it will actually give you access to the Jupyter Notebook, which is basically the equivalent of File Explorer in Windows. But to enter the Jupyter Notebook, it will actually ask you a password. But don't worry, that password is always the same. Jupyter written right here. So it's big J, UP1, T, 3, big R, and an exclamation point. Again, I will leave this password in the description down below, so you can just copy and paste it, and then click on log in. And then inside, you will have access to a Jupyter Notebook, which is basically where you're gonna input all your files. And basically, we're gonna use that space as if this was our local computer. We're gonna download the Stable Diffusion XL model, input our training images, our regularization images, and then we're gonna start the training. And I assure you, it is very simple. I did it really so many times that I could probably do it in less than 5 minutes. And it's really easy to do. So the first thing that we're gonna need to do is download the Stable Diffusion XL model. And for this, you're gonna go inside the Stable Diffusion Web UI folder, go inside Models, Stable Diffusion, and then here you're gonna click on Terminal, which will open this Terminal Linux window. And the next thing that we need is a link to the Stable Diffusion XL model. So for this, you can go on Hugging Face, go to Files and Versions, select the SDXL base 1.0, and then here you're gonna right click on Download and copy link. And then here in the terminal window, you're gonna type wget space, and then paste the download link, and then press enter. And as you can see, it will automatically download the Stable Diffusion XL model inside our folder. And you can basically use wget to download anything from the internet directly inside the folder. And as you can see, in only 16 seconds, the Stable Diffusion XL model is downloaded inside the folder. So now we can close this, we don't need it anymore. Then we're gonna go back to the root folder inside Workspace, and here we're gonna create 2 brand new folders. A folder where we're gonna input our training images, in our folder with our regularization images. So I'm gonna right click, create a new folder. I'm gonna write that folder as in mini Alcock. This is where I'm gonna put the training images. Then right click again, new folder, and I'm gonna input something like woman for the regularization images. So then I'm gonna inside the mini folder, I'm gonna select my training images, and then I'm gonna drag and drop them inside the folder, just like that. And now I'm gonna go back to Workspace, go inside the woman folder, and then do the same with the regularization images of a woman. So again, select them, and then drag and drop them inside the folder. And there you go. Now every image we need are inside these 2 folders. So now I'm gonna go back to my pod, click connect, and then select the second link, which will open the Koya SS GUI. And then again, if you're one of my Patreon supporters, you will have access to a bunch of RunPod presets that are configured to use inside RunPod. All you need to do is just select a preset and then drag and drop them in the root workspace folder, just right here. And then now we're basically gonna do the exact same thing that we did previously. We're gonna click on LoRa, click on configuration file, and then we're gonna input the path of our configuration file. And if you want to know where it is located, you can just right click and then click copy path and then paste it right here. But do not forget, there is one thing that you need to do, and that is to always put a backspace before workspace, because otherwise this is not gonna work. And then you're gonna click on load. And as you can see, not only it has found already automatically the SDXL model, but it has also populated the entire training parameters. You really don't need to change anything. You are almost literally done. But of course, if you remember correctly, we're still technically not done, because we need to first create the new folder structure and capture the image using blip. Now again, for this it's very simple. Here you're gonna click on tools, click on deprecated, then you're gonna input the same information as we did previously. So in our case, if you remember correctly, for the instance prompt it was Sasha Loss, woman for the class prompt. For the training images, they are located in the Melee folder, so you're gonna right click, copy path, then paste it right here. Again, do not forget to input a dash before the workspace, then the folder for the regularization images. So again, same thing right here, right click, copy path, paste it right here. Do not forget the backspace. Again, 20 repeats. And for the destination training directory, I'm just gonna copy and paste it right here, and then choose a name, something like Melee _ Alcock - Sasha _ loss. And then you're gonna click on prepare training data. And as you can see, if you go inside the Jupyter notebook, you will see a brand new folder appear that inside has the same folder structure that we created on our local computer, with the image, the log, the model, the regularization images, etc, etc. And then do not forget to click copy info to folders tab, so that when you go inside training and then folders, all the folders will be automatically populated. And then here you just need to choose a name for your model. And for this, of course, I'm gonna choose the exact same name as the output folder, Melee _ Alcock Sasha_loss. And well, we're basically done, right? Everything is already done for you. You don't need to change anything. We can already start the training, right? And do not forget, we forgot something, and that is the image captioning. Because again, if you go inside the image folder and inside the 20 Sasha woman, you see that we only have images. We don't have the caption for each image. Now for this, you can either do this beforehand, as we did previously, and then select the caption and then upload them on the folder, or you can just do everything inside the Koya SS GUI instead, and do the same thing that we did previously. Just go to Utilities, Captioning, Blip Captioning, then select our image folder to caption. In our case, it is this folder right here, so I'm just gonna right click, click on copy path, paste it right here. Again, do not forget the backspace, remove the image and the slash right here, so that you basically have this entire name and nothing else. For the prefix, do not forget to add Sasha_loss, and then click on caption image. And after around 2 minutes, you should see a caption for each image that you can again modify by double clicking on the file. Now again, I'm not gonna do it because I've already done it before, but you should definitely do it right now. And then to save the file, you're gonna press Ctrl S, and then you're gonna do that for each image. Make sure to caption it correctly so that you get the best results possible. And then once you're done with the caption, you can again go inside LoRa, scroll down, and then click on Start Training. And that's it. Now you just need to wait. However, you might be asking a question, and that is, well, that's great and all, but how do I know when something is finished? Because I don't really see any terminal window. And yes, it's true, and there is no terminal window, but there is something a little bit similar. Now, it's not as good as the real terminal window, but you're still gonna have the same information. And to see this, basically, when you need to do is just go inside the logs folder and then double click on the Koya SS.log, and you scroll down, you will see that the training has started, exactly as if this was your local computer. Now because it is simply a log file, like it is just a text screen, it will not automatically update. So if you want to see the progress, each time you need to close the file and reopen it again. And yeah, I know it's a little annoying, but you're basically not gonna spend a lot of time looking at this log anyway, because what's actually important is where your models are gonna be saved. Because now if you go to workspace, then go inside the folder we created and go inside models, this is where all the models saved every n epoch are gonna be saved. Now obviously I've already done the training before, so here I'm gonna show you the screen of a model that has finished training. As you can see, we have 10 different models, because since we trained for 10 epochs, and we save every epoch, it will basically save 10 different models. So now the question is, how exactly do we choose the right model? Do I choose this one? Do I choose this one? Do I choose this one? How do I even know? Well, the only thing that we really need to do is generate a few images with each one of those models and then compare them side by side. And again, inside RunPod, with that template, it is done very easily. All you need to do is just select all of your models, right click, click cut, then go back, go inside the Stable Diffusion Web UI folder, inside models, then LoRa, and then you're gonna right click and paste all of those models right here. And yes, I know I already have a few models already present, but for you, you should only have 10 models right here. And then here, back in RunPod, you're gonna click on the very first link, which again, as I said, will open the automatic 1111 Stable Diffusion Web UI. Because now if you click on this little icon right here, and then click on LoRa, you will see here all of your LoRa files. So now what we need to do is input a prompt, because now we're gonna generate a bunch of images with each one of those models to compare them side by side to determine which model we need to choose. So like for example, I'm going to input something like anime illustration portrait of Sasha woman, forest with lake in the background, high quality, beautiful face, action pose, etc, etc. And here do not forget to use the instance prompt and our class prompt. So if you remember correctly, this was Sasha and woman for the class prompt. You need to input those words to trigger the LoRa files. And also do not forget to input a fixed seed and a high resolution. So in my case, I choose 1024 by 1320. So now what I recommend you to do is you're gonna click on each one of those LoRas, one after the other. And I'm gonna explain why. So as you can see, here I have clicked on each one of those LoRas. They are now present inside the prompt, so I'm gonna close this window. And now I'm gonna select all of those LoRas, Ctrl C to copy it, and then I'm gonna delete everything except the very first one. And now if I click on script, then XYZ plot. For the X type, I'm gonna choose prompt SR, and then here for the X values, I'm gonna paste the name of all the LORAs I copied previously. And then after each and every LORA, I'm gonna input a comma. So comma here, then comma here, here, etc, etc. Now what this will do, and why this is so cool, is that this prompt SR script will basically replace the first value that you see right here inside your prompt with all the next values. So basically if you input the first value right here, it should be the same in your prompt. So it's gonna look for that value in the prompt and then replace it with all the next values to generate a sequence of images, and everything will be done automatically. So now for example, if I click on generate, it will start generating a bunch of images with every single LORA, where in the end you should have something like this. Now I've already copied and pasted this image before because I've already done the training, I've already done the generation, but then in the end you should have this entire sequence with each and every image generated with a different LORA. And now your goal is to determine which model is the best. Which model do you need to choose? And the problem is that a lot of people actually choose the wrong model. Because now let me ask you a question. If you look something like this, right? Which one would you actually choose? You will probably choose this one or this one, right? Because it looked the most like the character, right? Well, this is actually wrong. Because those models that you see right here are already overtrained. So the thing with LORA training, or with any training in general, your goal is to basically balance between flexibility and accuracy. Like basically accuracy is how accurate our image looks like the character that we try to train, and flexibility is how good it is at applying a different style. And your goal is to find the right balance between all of those models, which can be very, very tricky, because most people when they see those images, they would usually choose a model that is more accurate than flexible. And I mean, in a way, there is nothing wrong with that. It's really up to you which one you really prefer. If you prefer a more photorealistic model, you should definitely choose a model that has more training. But if you are like me and you prefer a more flexible model, you would probably choose a model with a little bit less training. So like for example, if I were to choose a model right here from all of those 10 models, I would probably choose the model number 3, which not only still look like our character, but still retain that style. Because do not forget that our base prompt was an anime illustration portrait. And if you're trying to generate an anime illustration portrait and your image looks like a photo, you have not chosen the right LORA. I mean, at least in my opinion. Now, there are some people that are gonna say, but look at this model. This doesn't look as good as the one right here, for example. How can you choose this model over this one right here? Well, again, first, it is just a matter of personal choice. And second of all, there is a way to make the final image look even better without compromising the flexibility. And that is by using high-res fix. This is an absolutely amazing option that will make your final image made with LORA even better. So like for example, in our case, I chose the third model. So here, instead of 1, I'm gonna input 3. Then for the script, I'm gonna choose none. I only want to generate images with that model. I'm gonna keep the exact same seed, the exact same parameters, the exact same prompt. I'm just gonna enable high-res fix. For the upscaler, I'm gonna input ESR again for X. For the iris step, I'm gonna choose 30. For the denoiser strength, I'm gonna input 0.4 and then upscale by around 1.5. And I'm gonna try with those parameters first to see if the final image looks better. So now if I click on generate, and this is our final image. And as you can see, not only we still retain the accuracy of the model because it still looks like Millie Alcock, but at the same time we still retain that absolutely amazing style that looks like a painting. So when you go and compare that image to models that are more trained, you can see that there is a huge difference in quality. And again, in my opinion, if I had to choose a model, this would probably be this one. It is very flexible and still retain the accuracy of the character, which as you can see, can create some absolutely beautiful images. I mean, those images looks absolutely gorgeous and you can really do anything you want. The sky is the limit, because if you try to do the same thing with more trained models, you will never be able to achieve this level of quality and flexibility. So yeah, in my opinion, be careful of one model you choose and prefer flexibility over accuracy, because accuracy can always be made better using the iris fix option. Oh, and also if you want to save that image as a LORA preview, all you need to do is just click here, select the LORA model, click on this little icon, then scroll down and click on replace preview. And now as you can see, we have this image preview for our LORA model, which looks really cool. And then now once you're done and you want to save the model onto your computer, all you need to do is just right click and and then click on download. And now you are done. Now of course, if you really want to find the right model for you, you should definitely generate a few more images using the same method I showed you so that you can find the best model for you. And there you go. Now you should know everything that there is to know on how to train a LoRa on a Stable Diffusion XL model. So as I said previously, if you are one of my Patreon supporters, you should now have access to the Koya Auto Installer, the thousands of high quality regularization images for training, the Stable Diffusion XL training presets for both local and RunPod, and of course the 4 different LoRa models. And also don't forget to vote on the poll to choose which LoRa you want to have next. And Patreon also gives you priority support, so if you have any issues during the installation or the training process, just send me a DM and I will do my best to answer you as quickly as possible. So yeah, there you go. Now that you know everything, you can now go out there and have some fun. So enjoy. And there we have it, folks. Thank you guys so much for watching. Don't forget to subscribe and smash the like button for the YouTube algorithm. Thank you so much to my Patreon supporters for supporting my videos. You guys are absolutely awesome. You are the reason I can make these videos for you, so thank you so much. And I'll see you guys next time. Bye bye.